What's up, everyone? Welcome to HVAC Unfiltered, the show where we keep it real about the heating and cooling world, and we talk about real life experiences that a lot of people don't know of when they come into the HVAC trade, whether it's working or whether it's moving into a new house and having air conditioning or central air, furnaces, first time home buyers, stuff like that. Things that I kind of want to make the new homeowner or new technician aware of. Um, when we're coming into a new season, say we're coming into heating season, which we are coming into now, where we're sort of on the in-between side, and we kind of want to take care of problems before they arise. So, as always, I always talk about maintenance. Maintenance is a number one thing. Um, but we're going to talk about a bunch of different topics, and I'll even get into some real world experiences that I had or have had um, in the past 30 years of doing HVAC. It's like 29 years or something, 28, 29 years. Um, but all said and done, my name is Rich Ingalls. I own Seashore Comfort Solutions out of Gloucester, Massachusetts. Um, we've been in business since 2018. I've been doing HVAC since 1997 in the commercial and residential areas, um, installation service, and I'm getting into a lot of design stuff. You name it. I try to get involved with anything that has to do with HVAC. This is my entire life. This is everything I know and love. Um, so the first thing that we want to talk about today are things that new homeowners want to look out for when they are either looking to purchase a home or have already purchased a home and are now in the all right, now what do I have to take care of phase of home ownership. When you first go to look at a new home or at your new home, um, take a look at the machinery. If it looks old, it probably is, um, and it's more than likely less efficient than the new machinery, or in fact any of the even newer machinery than the age that it is. Um, but don't be tricked either. There's a few machines out there that are still manufactured the same way that they were manufactured 20 and 30 years ago. So they kind of look old even if they're brand new. So they'll be shiny and stuff, but they'll still look like an old style machine. Um, but your best bet is to call in a technician and have them take a peek at it and give you a full assessment on what the machine is expected to do and the life expectancy of it thereafter. If you have air conditioning in the house, central air conditioning in the attic, it's definitely a good idea to get up there and take a look yourself, because the home inspectors and stuff don't specifically look for um, visible rust and stuff like that. They'll mention things, but they're not really well versed in the HVAC world. So if go up there, take a peek at it yourself. If anything looks questionable to you, it's definitely a great idea to have a technician come in, take a peek at it, and give you their opinion on life expectancy of the machine and or any preventative maintenance steps that you can take to keep the machine running as long as possible. If you have heat pumps in your home, this is a big thing too, where a lot of people are changing over to heat pumps and they're not really familiar with the operation of the heat pumps. So a lot of these new heat pumps, they'll turn the outdoor unit on first, get the condensing unit cranking, get the compressor running, send in hot gas to the indoor unit to heat that up without the fan running. And then after the coil gets hot enough, anywhere between say a minute to up to like 8 or 9 minutes, depending on a lot of uh, you know, feature, whatever variables, um, then the machine will kick the indoor fan on and start blowing warm air around. So the idea is they don't want cold air to blow at first, so they want to wait until that coil gets nice and hot and puts a good load on the indoor unit. Um, so it's just something to kind of be aware of. Plus, with heat pumps, after they run for a little while, they may go into a defrost phase where the outdoor unit senses that there's frost on the coils themselves, and it wants to evaporate and melt that ice, because once you get ice on the coil, you start losing efficiency of the coil itself, because you're decreasing the surface area of the coil that's being affected by the airflow. So the machine will actually switch into a cooling operation and shut the outdoor fans off in order to get the outdoor coil hot to evaporate and to melt off all the ice. And you see steam pouring off the thing. Only once in a while now with these new machines, they don't really go into a defrost too much, because the outdoor fans really crank a good amount of outdoor air across the coil, putting heat into that coil. But it's just something to be aware of. So when the machine does go into a defrost, it does blow cooling in the house. Most of the time there are electric auxiliary heat kits in air handlers that would turn on to compensate for the cooling effect. So it'll still kind of heat the house a little bit, but it won't be blowing at 100 and something degree air. It's going to be on the 80 or 90 degree side, most likely at the most. And then after the defrost phase is finished, a couple of criteria have to be met in order for it to switch back into heating mode. And then the machine just heats as normal. So you wouldn't really realize it if there is an auxiliary heat kit in the machine. But if there isn't, you may notice a little bit of a cooling effect for that 1.5 to 9 minutes, whatever it is, for the defrost cycle to take place. But it's usually not that long, and you really don't even realize it unless you're sitting near the condensing unit. If you're out in the house on the condenser side of the house, you might actually hear the condenser switch over into a cooling mode, and back and forth. But it's nothing to be worried about. We had one customer call in when the machine went into a defrost, and I don't know, she may have indulged in some adult beverages earlier in the day, and the machine went into a defrost, and there was crazy amount of steam coming out of it, and she said the machine was on fire. And and we were like, no, it's most likely it's a defrost. It's nothing to be worried about. And then when the tech arrived at the house, they discovered the machine running normal, no issues on on recall functions. And she said that she had her son pour his Coke all over the unit outside, and he put out the fire. So we ended up having to clean the whole condenser and everything. Or it just turned into a kind of a crazy nightmare of a service call, where it wasn't really even a service call in the first place. So don't pour Coke on your condenser. That's the tech tip of the week. Some other times when you when you see a heat pump freezing up outside, they try to go into a defrost cycle and they can't defrost themselves. Usually that's a refrigerant charge issue, or even a outdoor fan, perhaps, if the outdoor fan had failed. So one thing to do is, if you do have a heat pump, keep an eye on it every once in a while. Poke outside and see if there's ice forming on it. Make sure the condenser fans, the outdoor fans, are running at full speed. They should be running at full speed all the time, unless they're in a defrost cycle. When the unit is heating, if it's not running heat, the outdoor fans aren't going to be running, so don't expect them to. But if you do see ice forming on the outdoor unit, and after a defrost cycle the machine still has ice on the outdoor coil, it will start to build up even more. And we've had some machines that end up looking like igloos on some of the older machines because there were no protection controls, low pressure controls, low temperature controls. That would lock out the machine once it sensed enough ice on the coil. Because what happens is if you don't have enough refrigerant in the system, the compressor can't compress enough refrigerant to make it hot enough to influence that temperature of the coil to defrost the ice enough. Usually it does it every like 90 minutes, 60 minutes, depending on set points. But if it's continuously frozen, it's going to continuously try to defrost itself, and it can't do it. So what we end up doing is we'll shut the machine off, put it into cooling, pull the condenser fan leads off, and just let the condenser run and get as warm as possible. Hit it with a heat gun. You can spray alcohol on it too. Isopropyl alcohol is excellent because it doesn't freeze, so it helps lower the freezing point of the water and helps it defrost a little bit quicker. But first things first is I would just shut the machine off at least. If you do notice that, call us in and we'll get everything taken care of for you. I've had a lot of experiences with some commercial customers that they want to try to save as much money as possible, but they end up wasting a lot of money in the process. We had one customer where they wanted to capture heat that was generated by a big furnace that was it was making heaters, a big commercial customer, and they ended up putting some fin tube baseboard heating elements above the furnace to just capture some heat to put it into water, to use that water for some other process down the line. And one of the pipes ended up bursting because they didn't have a high pressure relief on their heat exchanger. So it was just a huge catastrophe here. If it's like just don't cut corners when you're trying to do stuff. That's pretty much where I was trying to go with that. We have a lot of customers that are trying to save money. I get it, but it ended up costing him, I think it was $11,000 in water when the water pipe burst on Saturday morning and no one was there. And the water continued to run until Monday morning at 6 when he walked in the door and got the water all shut off, but he ended up having to pay for it. So, you could have done a job for $12,000 that would have taken care of all of these issues and been done correctly. That's the big thing. So one other big thing that I had was a pretty cool story. Was I used to work at a company that did the heating and cooling for Boston, the Symphony Hall in Boston, when Seiji Ozawa was the conductor, and I think it was right around the time when they were switching over. I think it was Levine that came in after him, but it was right at that time period, and I think it was right in the 2000 range. But I got to do a lot of stuff in the Boston Symphony Hall, which was unbelievable as far as some of the machinery that you get to see that was installed way back in, I would say somewhere in the 60s to 70s range, 1960s to 1970s. Some of the machinery that's still there, was still running perfectly because it's all maintained. And they had a large steam-driven absorber that cooled the entire Symphony Hall area, the hall where the orchestra played and everything. And it was really cool because it's like when you sit in there and you're watching a symphony or you're watching something, whatever, you don't really realize the amount of work that needs to be done to heat and cool that space quietly. Quietly was the number one thing. Is most things in our world run at 60 hertz, which is a in a 60 hertz sine wave is actually kind of a base note. It's really low frequency, so you can actually feel the pulses if things are designed improperly, and if things are running incorrectly. So the indoor blower on the main Symphony Hall was running in the 11 hertz range, which is ultra low frequency, below the frequency range that the human ear can hear. So these are all like just really cool things that I kind of encountered along the road. When you go in, this was cool. When you go into the where the curtains are and everything, this was back in 97, 98 probably. One of the guys that we worked with found a piece of string, like twine, wrapped around an I-beam way up in the curtain section, whatever they call that, where all the ropes are and everything. And the guy pulled the rope up, and it had a little bottle of whiskey with a cork, an actual cork top in it from who knows when. So the guy that used to run the curtains way back in the day would do his thing with the curtains, pull his bottle up, take a couple of pokes off of it, and drop it back down. I thought it was pretty cool, and then he just left it there. He dropped it back down and just left it hanging. So who knows how long that bottle's been hanging there. It was just a pretty cool thing to see. So that's a lot of the commercial stuff that I encountered back in the day was, downtown Boston area, just outside of Boston, North Shore, and up in Marblehead and stuff like that. We did a lot of residential stuff up in the Marblehead, Swampscott area, and a lot of commercial stuff down in the Boston, Brookline, Allston type of area. That was a pretty good spot. First when I started, we were doing, I worked with a company that was out of Burlington, that did a lot of the big clothing stores in the area, the TJ Maxx's, the Marshalls, and all of that stuff. And we covered everywhere basically on the East Coast, but our part of the company, we covered from Maine to, I would go down to Connecticut, down to like the New York border of Connecticut. Some of the other guys would do Jersey, and I did Pennsylvania a couple of times, doing filters at all these stores. So I'd go out for 2 weeks into Connecticut, say, and I would start in southwest corner of Connecticut and Stamford. I think I was doing Bed Bath & Beyonds at the same time, so it was 5 calls, all maintenances. Basically I was just doing filters in, filters out, and then find a hotel in the first call's town the next morning so I could sleep overnight, wake up the next morning, and then go right to the first store, and then do 5 stores along the state of Connecticut. And over a period of 2 weeks, I would finish the entire state. I'd go back to the shop, load back up again, and then head out to Maine. And we'd do Maine, Vermont, New Hampshire, and then come back home. And then it would be back out in Pennsylvania, Jersey, Connecticut, nonstop. And it would just be a constant cycle of filters. And that's when I started sort of teaching myself how the machines worked, because I was out on my own. I had nothing else to do at the end of the day, so I would finish doing my filters and stuff, and then I would just start looking at the schematic on the machine, or I would just start watching it run, manipulating the condenser as far as covering the condenser up, watching pressures rise. So I learned a lot of this stuff when I was just out on the road, doing things by myself. I was by myself the whole time, and then another guy would follow in another truck, a week behind me, doing pressure washing. He would pressure wash indoor coils, outdoor coils, all that stuff. It was crazy. It was a nonstop cycle. And I'd like to get more into that kind of thing with, a specific company. If we could find a specific company that was looking for an exclusive HVAC corporation or HVAC company, we would be more than happy to talk about that. I'm looking for any kind of commercial contract customers. That's like the big thing coming up for next year is going to be commercial contract customers, and working more into contracts for our residential customers as far as different tiers. If we wanted to do one maintenance a year, two maintenances a year, stuff like that. We could also monitor houses during the winter. A lot of our customers go down to Florida. And a lot of summer houses up here, so we have a whole safe full of keys that we can go in and take care of all your stuff. If you monitor your temperatures, or if you want us to monitor your temperatures, we can go and check on the house if we see that there's a deviation from set point greater than X. If you want us to, or if you notice it, you can call us and see if we can take care of it. So let's see, what else did we want to talk about today? This is totally unscripted, but I have a script that I work off of. So there were plenty of, these are possible nightmare jobs. So we had a customer call and say that they wanted to have a central heat pump installed in their attic, inducted to the upper level of their home, and have a couple of drops pop down to the lower level. There was a sitting room, and I think there was a living room, kind of like family room type of area on the lower level. And I went out and looked at it, and this is kind of when we were starting, so it was something like I wanted to get as many jobs as I could to keep everybody busy. The number one thing is like trying to keep all the guys going, because if they're not working, we're not making money. We're not going to, well, we have to, we're still going to pay them, but we're not going to make any money to be able to pay them. So I ended up pricing the job out. It was an expensive install. It was a difficult house. A couple of vaulted ceilings with the condensing unit on the opposite side of the house of where they wanted the air handler. So the piping was going to have to go up through an interior wall, and I told the guy I was totally against it and didn't want to do it, but I priced it accordingly, and if you want to pay, what I say is anything's possible. It just costs more, because it takes a lot of planning. So I remember Dave and Nick did the job, and the customer was okay if we had to open up walls to trench walls, which we ended up having to anyway. And then there was some, the wall that we opened up turned out to be an old exterior wall that had drywall on it, and then it had shingles with, it was all stick built too, so it was all like 1x6 planks, all nailed to the side of the house. So we ended up having to cut a whole bunch of holes trying to get the piping up, just to get the piping into the attic. And then I think it was when he was trying to do some ducting, we ended up having to, he drilled a hole in the floor and stuck his camera down. We looked into the hole. We didn't see anything. He started cutting, and under a piece of insulation was a labyrinth of water piping. He ended up whacking a pipe, and water just went spraying all over the place. And he ended up finding the main of the house, shutting it down, and eventually the water stopped. We called our friends at New England Gas. They came up and fixed all of our problems. So shout out to New England Gas Systems out of Danvers. They do some of the best plumbing work on the North Shore. So if you need anything done for plumbing, definitely reach out to them. Natural gas stuff, boilers, heat pumps for pools, stuff like that. They do all that. So anyway, we finished doing the job, and the customer grabs Dave and he says, I can't believe you guys got this all taken care of. I had 5 different people out here, and everyone said it couldn't be done. And And I looking back, I should have said to him it couldn't be done because it was just a nightmare of a job, and it went right to the extent of the budget of the job. Um, but yeah, looking back on that one, I probably should have just told the guy I couldn't do it because it was an absolute nightmare job. Um, the the other thing that we're trying to get more commercial clients into is the changing into the transition into either heat pumps or into the hybrid heat pumps, the gas-fired furnace with the low temperature heat pump to supplement it. Um, that's going to be a real big thing for the future, where the new heat pump units are more capable of producing more heat at lower temperatures than they were 20 years ago, even 10 years ago, especially on the commercial side. So if there's a way that we can supplement the gas usage on a commercial roof, um, people should take advantage of it. It's a real big talking point, I think, for the energy conservation community. Um, just because it's, if you think about, well, people don't really think about it, but the furnaces on gas-fired rooftops are only 80% efficient. Most of the time, they do have higher efficiency furnaces, but I'm going 99% of the time they're going to be an 80% furnace on a gas-fired rooftop. If you could use a heat pump that was 100% efficient down to 30 degrees, 100% efficient, meaning every BTU that heat pump creates is being put into the house. There's no byproduct. There's nothing going up a chimney, up out a flue, anything like that. We're strictly making BTUs and putting BTUs into the house or building. If we can get 100% efficiency down to 25 degrees, that would be the most ideal way to do it, because the furnace isn't really even 80% efficient when it's 50 degrees out, because you're wasting BTUs at that point. If it's a 60,000 BTU or 100,000 BTU furnace and you only need 45,000 BTUs to warm the space up, warm the building or house up 1 degree, then you've wasted 15,000 to whatever, 35,000 BTUs of heat out the flues, or just kind of dissipating, or you've overheated the space. So the heat pump kind of gives you that third stage, where it would be first stage heat pump on the rooftop, if we're talking commercial rooftops. First stage heat pump. Second stage would be first stage gas heat, and then second stage would be second stage gas heat. Yeah, third stage would be second stage gas heat. So you technically would have 3 stages of heat. That's pretty much the way to go. The units are a little bit more expensive, but the incentives through Mass Save do offset the cost of the increase in price to go with the hybrid heat pump rooftop. So there are other considerations to take when you're considering putting in a hybrid heat pump rooftop, depending on electrical feeds going up to the existing rooftop. It might be something where you need to have a larger feed brought up to that rooftop. The gas service is hopefully already up there, where hopefully you're replacing a gas furnace with a hybrid heat pump rooftop. So then you could also just have that included cost, where the gas pipe would have to be installed as well. So lots of things to kind of consider when you're talking about rooftops and commercial equipment and stuff like that. As far as like some current news, there's still some grumblings about the refrigerant changeover and a potential refrigerant changeover in the very near future, as far as the R454B and R32 machinery. Um, the machinery in the past of the, say 2024 and before was all R410A, or even before that R22. Um, we had another changeover in refrigerant because of regulations. The global warming potential of R410A was too high, so they wanted to implement a new refrigerant, um, which is R454B or R32. Um, R32 has been used in a lot of residential air conditioners for years, as far as the window-mounted machinery and the portable machinery. So it's nothing new as far as the refrigerant itself. R454B is a little more current, where they wanted to sort of design a refrigerant that would meet global warming potential criteria in the future. Not so much as just for right now, but if they did in fact implement a lower global warming potential number for us, they would R32 would end up probably being over the line of the low end for the new regulations if they do impose those. So R454B is probably the highest contender for that. If not, they might go into, they're talking about doing R290. I think it's R290A actually, and R600A. But those are still kind of out there. There are some refrigerators and stuff in residential applications that do have those refrigerants, but we can only use certain amounts of them because of the flammability or toxicity of those refrigerants. That's what's kind of, it's almost like they're preparing the refrigeration community for that changeover to the R290, which is propane, or R600, which is isobutane, for high flammability rates. With the R454B, which has a very low flammability rate, it's a 2L, which is a 2 is flammability, and L gives it a low flammability, the L moniker there. But with the service practices that we need to take with the R454B, they're sort of prepping us for the changeover to these higher flammability refrigerants, R290 or 600. But the reason they haven't switched us over to that, I think, right now is because of the amount of refrigerant we're allowed to have inside of a house that has a flammability rate of X or X plus whatever. So I think the refrigeration manufacturers, the air conditioning and refrigeration manufacturers, are trying to come up with other solutions to not have the refrigerant inside the house. When you have a mini split head on the wall in your house, there's a refrigeration coil inside of that head that is drawing, the blower is drawing air across to provide the cooling or heating effect in the house. If that coil in fact had a leak, then there's potential that a flammable refrigerant could be released into the house. It's not likely. Like I said, I've been doing this since 1997, and there's been one time in my entire career when an entire refrigerant charge has been blown off, but it was in an attic, so it wouldn't pose a problem to the people inside the house, I guess, but it still could. So it's not likely that you would have that type of catastrophic failure, that unless it was caused, unless someone caused it, which I get. So there's potential. You could have a problem if someone bursts a leak in your system, and flammability and all that stuff. So I think what the manufacturers are trying to do is move in a direction of a different medium between the refrigeration and the indoor system, where they'd either transfer the heat or cool energy into water or a glycol mix or a brine, something, whatever, and then transfer, and then pump that throughout the house to all of the indoor units or whatever indoor, whatever it's conditioning, all said and done. So that's one thing that I need to talk to our customers about, so they know, so when I design these systems, there are certain criteria that I need to meet in order to be able to even install some of these machines in house. So when I go around and I scan a house, it tells me all the square footage of each room, the cubic volume of each room. And then when I go back to the office to design out the system on my Mitsubishi design tool, the new refrigerant criteria requires me to put square footage of rooms into the design. Square footage, how high the unit's mounted, what the elevation of the unit is compared to ground level, square footage, room height, and height of the unit, right? And if I put in these values and it's below the square footage allowed for the amount of refrigerant that the machine holds, it'll kick it back and say, hey, you can't do it. That room's smaller than 108 square feet or whatever it is, depending on the charge of the machine. We have a chart, so it's a chart that goes from 0 square feet to 10,000 square feet, and depending on the weight of refrigerant that's in the entire system, if we have 5 pounds, 10 pounds, whatever it is, it'll tell us how many square feet we're allowed to put the smallest head in. Because if we have a small room that's 110 square feet and I'm putting a 6 in there, I got 20 pounds of refrigerant in the machine. If that head somehow catastrophically fails and dumps all of its refrigerant into the space, then it's outside the design criteria. I'm putting people in harm's way, so I have to look at it from a safety point of view, but based on the criteria that they say, this is what we're allowed to do. Where my concern is we have a lot of I wouldn't even call them HVAC companies. I'm just going to call them. We have a lot of companies out there that put in air conditioning that don't follow the installation guidelines. Number one, from just basic refrigeration installation guidelines, but installation guidelines for the new refrigerants for the safety of themselves and the people that they're trying to provide comfort to. At the end of the day, you're leaving, and this is this person's house. So let's make sure that they're safe. That's my number one thing. Is I sleep pretty good at night because I know that when we do stuff, we're doing it properly, and we're doing it by the book. We use the equipment that we're told to use. We're doing it in the process that we're told to do. And I guess if you knock on wood, the track record says it all. Where we've hardly had any type of issues with installations that weren't either manufacturer related or application related, based on customer preference. Sometimes where I can suggest all of these options, but if a customer wants to go and come up with their own design or doesn't think my design is proper, and I say, okay, well, I'll do it the way that you want to, but on my contract it's going to say this is all based on your preferences, and then that way they can't complain when I'm back there again putting something else in to supplement the system that they designed. So that's my big thing. Talking about the tools that we use, it's kind of a good segue because I've got a lot of new tools where with the new refrigerants, we're not allowed to use drills that have brushed motors, or any type of tool or device that has a brushed motor. So all of our drills and everything have to be brushless. All of our recovery machines have to be brushless, or ECM sealed motors and all this stuff. So we've been getting into a lot of the NAVAC, or NAVAC, however you want to pronounce it, refrigeration tools, where they have a lot of reports that we can download through our apps. We have, all the guys have iPads that they can link up to their gauges, to their recovery machine, to their vacuum pumps and charging devices. And then when we do run the machine, we can run a refrigeration report on it, record it, and then print it out or email it in a PDF over to the customer, or just load it onto the customer's profile on our software. So when the next technician goes back there, they can scrutinize the original install against what they see now and see if there's any deviation in performance as far as refrigerant leaks, or whatever, anything that could be potentially broken. Like right now, one thing that customers want to try to think about, if they have cooling units, just straight outdoor cooling units, not heat pumps, I recommend putting a nice piece of pressure treated wood on top of it with a cinder block. Let the air continue to flow through it. That way it keeps it dry. But if you want, we could come out. We usually would pop the cover off the top of it, the condenser fan lid, and pull all the leaves and stuff out from inside the condenser section, because they just sit down in the bottom of that pan, and end up, they getting wet, and then you have just wet decomposing leaves sitting on metal it's all powder coated or painted or whatever. But if there's any kind of cracks or whatever in that stuff, it's just going to end up rusting. And we've had condensers where we go to pick them up, and the condenser, the compressor in the bottom of the unit stays on the ground, and we pick the condenser up and throw it in the truck, and then have to go back and grab the rest of it because it's all rusted. And a funny story though, one time it was at a travel agency I was at Harvard Square, where Dave and I, this was years ago, this had to have been 20 years ago, we got a service call for no cooling at the travel place. It was TRA Travel. I doubt they're still around. But we got a no cooling call, and we went inside, we checked it out. I don't remember if the indoor fan was running. I don't think it was. I figured most likely the fuse or the transformer was blown up because of what we found outside. We go around back, and there was literally just the bottom of the condensing unit, the bottom tray, and the compressor. The entire condenser coil, condenser fan, everything else was gone. And I think they even got some of the piping halfway up the wall as far as they could pretty much get to. What they did, they stole all of that to scrap it and get cash for copper. You could probably, for that coil and stuff, you probably got, maybe $15, 20, maybe $20. I don't know, back then it might have been like $20, $25, whatever. But they must have got refrigerant burns, because the thing was fully charged. It was a fully charged system. They just cut the pipes, and the refrigerant just blasts off. And that was an R22 machine, so that refrigerant's boiling off at minus 40 degrees as it's spraying out, minus 40 F. And so most likely they got some frostbite when they cut the pipes. There's almost no doubt about it, which is, I guess it's karma or whatever. But we ended up replacing that machine, I think, and then it might have been like when the guy delivered it, this is the story. The guy delivered the new one, and as he was offloading it from the truck, he dropped the thing on the ground on its side, from like 3 feet up, and he said, "Oh yeah, no, it'll be fine. Just put it in. Let us know if it doesn't work." The next day, the compressor was blown up in the thing. I don't know what ended up happening, but we ended up getting a new condensing unit. They brought another one over the next day. We were in freaking Harvard Square for like 3 days straight. No parking. It was a pain. But that's pretty much, that's. I've been all over the place today. I kind of tried to set a framework on this, but I just get on tangents and start talking about stuff. So if there's anything as far as like nightmare jobs that anyone else has encountered, definitely make sure you leave a comment down below. I'm going to try to bring Nick in, I think, next time, because he was talking about a couple of real life instances that he came across doing dry events. We do a lot of dry event cleanings. People think you don't need to do it. You really actually do. It's kind of crazy the stuff that we see out there when it comes to dry events. And as far as code violations that people don't know, and if they did know them, then they would probably change the way that they install their dry events, because some of these are crazy. But yeah, so we're going to end up having Nikki in here next time. Talk about some of his personal experiences. I've had a couple of really crazy ones. Just thinking of dry events, there was one I did at a health club in Boston, really like a high-end health club place, and we got a call for that the clothes weren't drying as fast. They were still wet when the thing said it was complete. So I went out there. I think it was a 12-inch vent, a big 12-inch dry event, and the 12-inch duct was completely full of lint from the dryer, and it probably went maybe 15 feet to the wall, 90'd up, and then in that, when it 90'd up, there were booster fans that were supposed to draw the lint and blow it outside. They were broken. I don't remember what I think. If I remember correctly, this was literally like 20 years ago. If I remember correctly, they were 120 volt dry event fans, and they had 230 volts going to them. So I think the motor, it was either like they were burnt up or something. I don't remember what the deal was, but the motors were burnt up on these. They were Fantech exhaust fans, dry event fans, real ones, whatever. So I replaced those, and we ended up pulling all the lint out of the duct. All these people did was wash white towels, so all of the lint was just white. It was crazy. And then when we got the new fans in, we kicked the thing on, and all of the dust that was left that we couldn't get out all blew out onto the street. It was right in the financial district in Boston, and it looked like it was snowing because we were the exhaust for the dryer came out on basically the one and a half story, the top story, the ceiling height of the first floor. But it was crazy because it's like you don't think about it, but once that dust keeps building up and starts making its way back into the dryer, then it either is going to get to the heating elements themselves. I don't know if it could actually, depending on the dryer. But that's where all these problems arise, is just from lint building up, or like when you have bellies in pipes and stuff, a lot of the lint gets settled down in the belly of the pipe, and then the next batch you dry, the moisture from that batch soaks into that lint, and then that lint gets soaking wet, and it just turns into a hard clump of wet lint, closing the vent down to about half the diameter that it should be. So that's why you're not drying your clothes fast enough. People don't think about this stuff, and it's a pretty straightforward thing to take care of. We pull the dryer apart, we clean the interior of the dryer into the base pan, we pull the filter out, we pull the plastic container out that the filter clicks into, we suck all that out. So Nick is well versed in the dry event cleaning stuff. I haven't done one in 100 years, so I'm going to have him talk about it a little bit next time. But I want a big shout out to Andrew at Streamography. All his people are excellent. They all they treat me good, and they get me rolling. And this one's tough because I'm solo, and it's like I don't know what to talk about. If I have someone that can cue me up, I can ramble on all day. But if you guys have anything crazy or wild stories as far as HVAC service calls, HVAC installs, rooftops, chillers, you name it, definitely put a comment down below and let me know. Something funny. Don't make them wicked long because no one likes reading a book. But um, definitely tune in next time. We'll see you. We'll see you then. Thanks for stopping in.